I'm reading the book Genesis, The Story of How Everything Began by Giorgio Tonelli. Giorgio Tonelli played a key role in the discovery of the Higgs boson, also known as the God particle, which earned Francis Englert and Peter Higgs the 2013 Nobel Prize in Physics. For his contribution to science, Tonelli was awarded the Commendatore of the Order of Merit of the Italian Republic in 2012, the Enrico Fermi Prize from the Italian Physics Society, and the Special Breakthrough Prize in Fundamental Physics. He is a professor of general physics at the University of Pisa and the visiting scientist at CERN. Introduction. The Grand Narrative of Origins. 40,000 years ago, when the second wave of Homo sapiens arrived from Africa, many areas of Europe were already populated by Neanderthals. Organized into small clans, they lived in caves that today provide unequivocal proof of a complex symbolic universe. Walls painted with symbols and drawings of animals, bodies buried in fetal positions, bones and large stalactites arranged in ritual circles, plentiful evidence, in other words, of a culture that had in all probability also developed a sophisticated spoken language. It is possible, then, to imagine hearing a story of the origins of the world already resounding in those caves, the elders transmitting it to the young through the power of words and the magic of memory. The echo of an ancient narrative. It should be thousands of generations before Hesiod, or whoever we know by the name, left us in his Theogony, a written account of how our universe came into being, woven from poetry and cosmology. This ancient origin story continues to evolve to this day, thanks now to the language of science. Equations might lack the evocative power of poetry, but the concepts of modern cosmology, a universe that was born from a fluctuation in the quantum void, or from a cosmic inflation, can still take our breath away. All such stories spring from one simple, inescapable question: where does all this come from? It is a question that still resonates in every part of the world, among people belonging to vastly different cultures. It is a point of a commonality in otherwise distant civilization, a question posed alike by children and executives, scientists and shamans, astronauts, and those small, isolated population of hunter-gatherers who survive in areas of Borneo, Africa, and the Amazon. A question so primal that some have even imagined it must have been handed down to us by the species that came before. Foundation, myth, and science. For the Kuba of the Congo, the universe was created by great Mumbambo, the lord of a dark world, who vomited up the sun, moon, and stars in order to free himself from a terrible stomach ache. According to the Fulani of the African Sahel, it was the hero Dundari who transformed an enormous drop of milk into earth, water, iron, and fire. For the Pygmies of the forests of equatorial Africa, everything came into being with a huge turtle laid its eggs while swimming in the primordial water. At the origin of mythological narratives of this kind, there always seems to be something indistinct that most troubled us: chaos, darkness, a liquid and formless expanse, a tremendous fog, a desolate earth, until a supernatural being intervenes to shape things and bring order. This is where the great reptile comes in. The primeval egg, the hero or the creator who separates the heavens from the earth, the sun from the moon, and gives life to animals and man. The creation of order is necessary because it establishes the rules, providing the foundations of rhythms that mark the life of communities, the cycles of day and night, the changing seasons. Primitive chaos triggers ancestral fear, the terror of falling prey to the forces unleashed by nature, from ferocious beasts and earthquakes to droughts and floods. But once nature is induced to follow the rules dictated by the hero who has brought order to the world, humankind is able to survive and reproduce. The natural order is reflected in the social one, in the combination of norms and taboos that define what is allowed and what is strictly forbidden. If the tribe behaves according to the rules established by that originary pact, then this stockade of rules will protect the community and prevent its disintegration. From such myths as this, other constructions follow. They morph into religion and philosophy, art and science, disciplines that will hybridize and fertilize each other, and allow enduring civilizations to flower. Yet their interweaving breaks down when science starts to develop out of all proportion to our other speculative activities. From that moment on, the sleepy rhythm of societies, unchanged for centuries, is ruptured by a succession of discoveries that will profoundly alter the existence of untold populations. Suddenly, everything changes and continues to change at a vertiginous pace. The emergence of science ushers in modernity. Societies become dynamic, subject to continuous transformations. Social groups enter a period of ferment. Dominant classes undergo profound changes, and in the course of just a few decades, the centuries-old balance of power is disrupted. But the most profound transformation do not concern the way in which we communicate or produce wealth, our medicine, or mobility. The most radical alterations are in how we look at the world, and therefore our place within it. The original story provided by modern science very quickly acquires unrivaled consistency and complexity. No other discipline can provide explanations that are more convincing, verifiable, coherent, or consistent with regard to the myriad observations supplied by scientists. And yet, despite the notion that we have progressively lost something of the magic and mystery that had accompanied us for millennia, the vision of the world that we have gradually developed through science is actually more amazing than anything we could have imagined before. It retells the story of our origins more imaginatively and powerfully than any methodological narrative. In order to construct this story, scientists have had to scrutinize the most hidden and minute corners of reality, and have explored the remotest worlds, coming to terms with states of matter so different from anything previously known to us as to nearly blow our minds. From science, we derive the paradigm shifts that define our epochs, and that irreversibly modify our relationships. And it is the ceaseless pressure of scientific discoveries that sets the tempo of this subterranean development. Like the forces exerted upon the Earth's crust by white-hot magma, sometimes breaking it apart and irreparably transforming the landscape above. Our lives are conditioned by the story of the origins of the universe told by science. It profoundly shapes the foundations on which we will build new social arrangements, opening up vistas full of opportunities and risks, and shaping the future for coming generations. This is why, just as in ancient Greece, everyone had to know the foundation myth of the polis, the origin story that is provided by science ought to be familiar to everyone. But for this to happen, we must first overcome a considerable obstacle. We needed to come to terms with the difficulty of a scientific language. A complicated language. It all begins with an apparently marginal episode that took place just over 400 years ago, and which has as its protagonist a Pisan professor of geometry and mechanics at the University of Padua. When Galileo Galilei began to modify the strange tube manufactured by a Dutch optician, converting it into an instrument for examining celestial bodies, he could hardly have imagined the trouble it would get him into. Much less could he have foreseen the turbulence that his observations would create across the entire planet. When Galileo sees through his system of lenses astonished him, the moon is not, after all, the perfect celestial entity described by the most authoritative texts. It is not composed of incorruptible matter, but has mountains, craters with jagged edges, and plains similar to our own. The sun has stains on its surface and rotates on its axis. The Milky Way is a vast accumulation of individual stars. The starlets surrounding Jupiter are orbiting satellites that resembles the moon. When in 1610 he publishes all this in his Sidereus Nonetius, he provokes, perhaps unwittingly, an avalanche that will undermine the system of beliefs and values that had prevailed for more than 1,000 years, and that no one had ever dared to challenge. Modernity begins with Galileo. Humankind frees itself from all protection and faces the vastness of the universe alone, armed only with its own ingenuity. A scientist no longer looks for truth in books, no longer bows his head before the principle of authority, no longer repeats formulas handed down by tradition, but subjects everything to the fiercest scrutiny instead. Science becomes creative research into provisional truth through sensory experiences and necessary demonstrations. The power of the scientific method resides in conjectures verified by means of instruments that allow the observation, measurement, and categorization of the most diverse natural phenomena. It is the results of these experiments, what Galileo calls sensory experiences, that determine whether a conjecture works or should be discarded. From his observations, irrefutable evidence is soon provided in support of the lunatic theories of Copernicus and Kepler, and our view of the world changes so radically that nothing will ever seem the same again. Art, ethics, religion, philosophy, politics, everything will emerge transformed by this conceptual revolution, which places humankind and its capacity for reasoning at the center of everything. The disorientations that this new approach will produce in a relatively brief period of time are so profound that it is hard to think of anything remotely comparable. Galilean science is truly revolutionary because it does not allow itself the right to hold back the truth, but instead relentlessly seeks the possibility of falsification, even in its own predictions. It welcomes the prospect of all the certainties established up to that point, crumbling if they turn out to be false. And it is self-correcting in the light of experimental verification. Finally, in order to stress test the increasingly complex conjectures that are being elaborated in its name, it pushes towards the exploration of ever more mysterious aspects of matter and of the universe. From this patient and self-critical approach, accounts are produced of elusive and apparently marginal phenomena. In the process of evolving a view of the world that is ever more sophisticated and complete, we end up mastering, down to the minutest detail, the most remote natural phenomena, and at the same time developing increasingly sophisticated new technologies. The price to be paid for this course of developing is the need to use increasingly complex instruments and a language increasingly remote from common speech. No sooner have we departed from the realm of daily life than the instruments and conceptual apparatus that govern our ordinary activities become inadequate. When we explore the minuscule dimensions in which the secrets of matter tend to be hidden, or embark on an exploration of those cosmic spaces that tell of the origins of the universe, we find ourselves in need of a very special equipment and years of preparation. This should come as no surprise. Even actual journeys of exploration and adventure across the globe require a great deal of preparation, effort, and specialized equipment. Think of extreme sailing, or climbing in the Himalayas, or descending into the oceanic abyss. Why should a scientific exploration be any easier? Anyone wishing to thoroughly appreciate physics, therefore, will need to labor for years to study group theory and differential calculus, and gain a command of relativity and quantum mechanics, as well as a field theory. These are all abstruse subjects, involving concepts and a language that are difficult even for those who have used them for years. But the barrier of a specialized language, which prevents most people from entering into the living heart of modern scientific research, can also be surmounted more readily. We can still use ordinary language to explain the basic concepts and to make the vision of the world that science is in the process of advancing accessible to everyone. Let me stop here and read